My name is Dr. Muhammad Javaid, and today I have to present my paper, which is titled Study on the Induced Voltage in Piezoelectric Smart Materials (PCT) using ANSYS Electric and Fuzzy Logic. So I am going to present it in the 6th International Exchange and Innovation Conference on Engineering and Sciences, Kyushu University, Fukuoka, Japan. So I have to start it now. So we human always try to provide the independent way out for operating the small electrical devices with minimum harvesting of energy. So we have very large number of methods to produce energy. Amongst all methods, the favorite is the vibrational energy harvesting due to its mechanical vibrations. So in this figure, we have a PZT material, and we have to work on it. So PZT means lead zirconate titanate. P for lead, Z for zirconate, and T for titanate is considered as the best piezo material. It is the world's most widely used and best piezoelectric ceramic material, and it can produce piezoelectric effect. PZT material is used to sense variations in stress, acceleration, heat, pressure, and energy by transforming them to electrical energy. So here in this slide, we have a piezoelectric crystal of PZT. The atoms of the unit cell are organized in symmetry as shown in the figure A. This one is the figure A. Here it is electronically neutral because of the perfect balance of charges as shown here in this figure, number B. If this material is stressed by applying a force, we have applied a force here. So due to the deformation of the structure and misbalancing of positive and negative charges in the material, the charges are induced here in such a way. The charges are induced here as shown here, as displayed it here, positive here and the negative one is here. This process spread over the material and causing the net positive and negative charges on the opposite faces of the PCT. Piezoelectric effect actually the ability of the certain materials to generate an electric charge in response to applied mechanical stress. So here I have used ANSYS as a simulation tool, and we know that simulation is always designed to replicate the physical behavior under specific circumstances. So ANSYS is a very powerful tool for the simulation. Here I have used ANSYS Electric 18.2 to simulate the piezoelectric material in order to determine the voltage on the sheet of the PCT material. So in this voltage analysis, I have used some specific parameters for the simulation. In the background, we have multiple metals specifications. From them, we can choose any metal or any material in the background of the ANSYS. So we can choose PZT from there. So the specification here to design the geometry and then meshing and then the voltage analysis here. So the parameters I have fixed like this. The relevance center is fixed at 0. Element size is fixed by default. Element order is linear. Size function is taken like adaptive. Transition is set at fast. Bounding box diagonal is fixed at 35,431 millimeter. Minimum edge length is fixed at 2000 millimeter. And I have target quality is fixed at 0.05. And I have set soothing on medium. I have set inflation transition at smooth transition. And I have taken here the transition ratio as 0.272, and I have taken growth rate fixed with 1.2. So this is the continuous domain. This one is the continuous domain, and I can convert it into a finite number of points called nodes and elements, which you are observing here in this figure. So after meshing, I got 2110 nodes and 342 elements. So the voltage, the value of the voltage determined here is the maximum voltage is 5 millivolts. So here, fuzzy logic is a form of many-valued logic, and fuzzy logic is a form of many-valued logic in which the truth values of variables may be any real number between 0 and 1. It is a form of artificial intelligence. It is a decision-making simulation tool, and it also provides a part of machine learning. You might have heard about the Boolean logic. It is just the crisp values, only 0 and 1. But here, fuzzy logic, we can take many values as we want between 0 and 1. So fuzzy logic is also a simulation tool for the simulation here for the PCT material. So we can simulate a fuzzy inference system. This one is the fuzzy inference system, using either the fuzzy logic controller or fuzzy logic controller with rule viewer blocks. So the rule viewer blocks is coming on the in the next slide. It means we can evaluate fuzzy system at the command line. Using the fuzzy logic controller, I have used traditional type 1 fuzzy inference system, Mamdani, and I can take Mamdani, I can take Sujino, but in this simulation I have used Mamdani only, because when we can compare Mamdani's and the Sujino values, some Sujino method, so we have output membership functions in Mamdani's model. We can have output distribution functions in Mamdani model. We can have crisp values obtained through defuzzification in Mamdani model. We can take non-continuous output surface in Mamdani model. We can take expressive power in Mamdani model. We can take less flexibility in Mamdani model. And in Sujino model, we have no output membership functions, we have no output distribution, we have no defuzzification, we have continuous output surface, and we have less interpretability, and but we have more flexibility in Sujino model. So I have used Mamdani model here for its broad system. So here in this study we have considered MATLAB fuzzy logic technique because still no one has used this simulation method for PCT material. In this simulation I have considered 3 inputs: force, displacement, charge, and one output is the voltage. And for the membership functions, the ranges are set. For the force, I have set 6 millinewton to 10 millinewton. And for the displacement, I have set 5 millimeter to 10 millimeter. For the charge, I have set 100 millicoulomb to 1000 millicoulomb. And the voltage is set from 1 millivolts to 100 millivolts for potential difference here. So then, this is the rules. These are the rules, the fuzzy rules. 27 rules are here, and they are prepared with the help of if and then statements. If and then statement is the very powerful statement, and we can develop fuzzy rules with the help of this statement. The fuzzy system shown here in the previous slide, and the membership functions are also from in the previous slide, and here are the rules are presented here. With the help of these simulation, the force I have taken here 9.04 millinewton, displacement here is 6.35 millimeter, charge is 284 millicoulomb, and voltage I got 5.56 volts, millivolts. So as displayed here in the rule viewer. And then there are the 3-dimensional and 2-dimensional graphs between force, displacement, and charge with potential difference. They are exposed below here. The 2-dimensional are below. Force and the voltage graph, voltage and the displacement graph, they are alike. So in order to have the Mamdani calculation, because I have simulated this PGT material twice, from ANSYS I have got 5 millivolts, and from fuzzy simulation I have got 5.56 millivolts. The results are very close. So now I have to use Mamdani's calculus in it. So here I have obtained C1, C2, C3, C4, C5 and C6. They are actually the membership values, membership function values, and it is used for the calculus of Mamdani model. So here we have the membership function for singleton value and the minimum value. Singleton value shown here is SI and the minimum value here is shown as RI. So with the help of this membership function value, simulated result is verified with Mamdani's relation, and we got 5.5 millivolts here. The difference between the values is very, very low, and with 0.01% error, just the 0.01% error here. So here is the comparison of the results. You can clearly see that ANSYS value is 0.005 volts, fuzzy is 0.00556, Mamdani's model is 0.0055. So ANSYS electric and fuzzy logic simulations, these are the simulation schemes can be functional to control complex structure like PGT material. Simulation with both software is an alternative method to find the decent results, and simulation is always needed to study the results before the fabrication, because the fabrication is high cost values. So there are countless values in fuzzy logic, and ANSYS is a very powerful software for simulation. In this research, I have found alternative techniques to discover the value of induced potential difference. The variance is just 0.005 volts between the two simulation techniques, and there is no difference between fuzzy and Mamdani values, almost no difference. Piezoelectric materials can generate voltages in the range of 0.001 volts to 0.1 volts. Consequently, it is confirmed that this PGT system has the tendency to induce the potential difference in certain range. By using these simulation techniques, we can have a very good idea that how much the system has the working potential. Maximum and minimum output of any system can be measured by these simulation techniques successfully. So this is the last slide for results here. I have put the results here, ANSYS electric and fuzzy, with the help of ANSYS electric and fuzzy logic simulation. So the simulated values are very close to each other, so results are verified. The output voltage current that is produced from PGT system is very low. The output voltage, the current is very low now. Therefore, charging time of the battery is increased. It can be utilized to charge a battery. The voltage obtained through both simulation by using Mamdani's principle is very much enough for charging any type of battery through the piezoelectricity. Our PGT system has the potential to develop voltages in the range of 1 millivolts to 100 millivolts. These PGT systems are needed for the sensors and actuators that can enhance the charging process. So this system has produced just 5 millivolts, and when we can use all the systems in series, then we can generate too much voltages. The obtained simulation results of this paper will be helpful in future in order to fabricate the efficient energy harvesting PGT systems. Thank you very much. And now these are the references, and thank you very much. Allah Hafiz.